Hello. So you're watching this video. This won't look too crazy to you because you would have already been in class a few times. This is section 1.7 that we're going to go through today here in a second. But for me, this is my first time kind of using this setup as to how we're going to kind of operate every single day in here. So I'm going to be teaching at the smartboard and using the Chromebook, or not the, yeah, I'm using my laptop to have myself online with the students online. So for you guys, you've seen this a few times. For me, on Thursday, September 3rd here, I am recording this, kind of going through my practice run and making sure everything's in order so that I'm ready to operate this way on Tuesday. So this is my first time running like this, so bear with me. So today, 1-7, we're looking at midpoints. Kind of the main thing that we're going to be looking at with midpoints today is really this first statement: find the point on a directed line segment between two given points that partitions a segment into a given ratio. Now that sounds a little wordy, sounds pretty mathy. What it means is between two given points and then into a given ratio, we're cutting it into the ratio of halves, okay, of two equal halves, two equal parts. So what we're really just looking for today is the middle of these line segments. The midpoint is that middle spot. So when we look at a number line, which is very rarely going to be the case, but we look at a number line, that's kind of the basis of this. What we're seeing is if I've got my point A sitting over here, point B on the other side, that midpoint is going to be whatever those two values are added up, cut in half, okay? So let's put this to an actual example. So what I see here, I've got my first point X at -3, my second point Z at 8. So I could do this a couple ways, all right? But I need to find the middle. One way you could do this is exactly what we saw up top. Take the 2 points, add them up, divide by 2. That is where your midpoint is going to be. So I'm going to take -3 plus 8 and divide it by 2. Order of operations is just having me get the top done first. -3 plus 8 is going to be a +5. And 5 divided by 2, you can just leave it as that 5 halves. You do not have to put it as 2.5 or 2.5, but you can. We typically are not going to see this stuff anymore. We're not really going to be using those mixed numbers. It's correct, but we're going to be keeping it with one of these two. You can leave it as that 5/2. So 5 halves or 2.5 is going to be my midpoint in this scenario. Now, I do want to just show you here, going back to the distance formula stuff, the distance that we did in 1.4, if I can find the distance between my X and my Z, which we did that by taking your new point and subtracting your old, so 8 minus -3 is going to be 8 plus 3, which is 11. Or if you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I can find that distance between the 2 points, in this case it's 11, and I cut that in half divided by 2, 11/2 is going to be 5.5, 5.5. What that means for us is the midpoint is 5.5 steps away from both my X and my Z. So from X, I'll go 1, 2, 3, 4, 5.5. There's that midpoint. From my Z, I can go backwards 1, 2, 3, 4, 5.5. Either way, I'm going to get to that 2.5 or that 5 halves in the middle. So there's two ways you can do this when we're looking at it in a number line approach. Okay, you can use that formula, which is going to come in handy in more often than the formula method is going to come in useful more often than the second way we looked at it, but this way is also going to be an option for you. You're just going to have to kind of piece it up a little bit more. We'll see a good example of that, I think, on the next slide. We could look at an example like that here. So the reason that this is going to be a little bit more complex than just counting is because when we've all of a sudden got 2 points that are not in a perfect vertical or horizontal line, you can't just count anymore. We cannot count that, okay? You can't count diagonally across a coordinate plane, right? You can only count left to right, up and down. So we've got this formula. might be kind of tough to see for you there. I'll rewrite it. The midpoint of any segment is going to be the two x's added up and cut in half. That's going to be the x coordinate of your midpoint. And then the two y coordinates added up and cut in half. That's going to be the y of your midpoint. Okay, so let's look at our first example. Now, you do not need a graph. You do not need a coordinate plane to do this. We're going to show you one on a coordinate plane. It's visual. It's nice. It's nice to see. But we'll look at the second example then and show you that you don't have to have that. With this formula, you do not have to have a coordinate plane. So when we've got AB, let's use some different colors here. If I plot point A at -2, 1, so that's going to be right here. That's point A. And then I plot point B at 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, and then go up 3. That's going to be point B for me. That's my line segment, AB. See, notice that I cannot count to a midpoint in this scenario. So what I'm going to do is use that formula from up top. I take my two x values, -2, let's look at the x's, so -2 plus 8, all divided by 2. -2 plus 8 is going to be a positive 6. 6 divided by 2 is 3. Then I'm going to take my two y's, a positive 1 and a positive 3. So I've got my y's at 1 plus 3 all divided by 2. Same thing. You're doing the same formula for both of them. Just make sure your x's stay together, your y's stay together. So 1 plus 3 divided by 2, that will be 4 divided by 2. That will simplify out to be 2. So my midpoint is going to be at the ordered pair 3, 2. And then I come over to my graph, 1, 2, 3, and then up 2, right there. You're going to know right away when you're graphing, if you make a mistake, you very well may end up with a point that's not even on your line. So since I ended up on my line, and it looks like I'm pretty close to right in the middle, I'm pretty safe. I feel pretty safe saying that is my midpoint. So the midpoint there from the formula is at the ordered pair 3, 2. Now, how can we do this without a graph? Well, it's very similar. It's actually the exact same thing. We are just not going to be graphing it and seeing it visually. So point E is at -6, 2. Point D is at 5, 7. I'm going to take my x's and do the same exact process. So for my x's, -6 plus 5 all divided by 2. -6 plus 5, excuse me, -6 plus 5 is going to be -1 divided by 2. You can leave it just like that. You can leave your answer as -1/2. Again, you could say -0.5. We don't need to. This is just fine, -1.5. And then looking at my y values, I've got a 2 and a 7, same thing. So my y's, 2 plus 7 all divided by 2. 2 plus 7 is going to be 9. That's going to equal 9/2. Again, you can leave it as 9/2 as that improper fraction, or you could say 4.5 if you want to as well. Now, to bring it back up to this situation, you can still turn these into what we talked about right here in green. You can still turn both of these situations into kind of counting. So if you're down here, let's give ourselves a little more room. If you're down here, you want to look at the x's. So for the x's, if I'm sitting at -6, which we'll say is right here, -6, and then I've got 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Ooh, nice, did that perfectly. Then I've got 5. So if we talk about the distance, if I want to know how far apart -6 and 5 are, you can count, or you can do that 5 minus -6, which is going to be 11, because minus a negative is positive. Or you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Either way, we have that distance of 11. Well, half of 11 is going to be 5.5. So I could take 5.5 steps. Let's put this over here. Half of 11 is going to be 5.5. I could take 5.5 steps from either point. 5.5. 1, 2, 3, 4, 5.5. And I would end up at this spot right here, which this is 0. I'm still going to end up with my -1/2. I'm not going to do that for y just for the sake of saving a little bit of time and keeping this a little bit shorter, but that's an example of the same thing we did on that first page, using kind of counting and distance on a number line. Do the same thing that we're doing with these functions. But I think most of us may be comfortable using the function for both the x's and the y's. It stays pretty repetitive, and you don't have to worry about losing track of numbers or anything like that. So what we see here, so this one's a little different. So what we're looking at is find the coordinate of A, the coordinates of A, if P is the midpoint. So P is the midpoint of this line segment. So if I've got P at 3 1/2 right there, and then I've got my B at 8, 3, I need to find that A, and it's going to be somewhere over here. Right? It's going to be somewhere over here, because if this is the first half of the line, the other half of the line is going to go this way. Now, I don't know exactly where it's going to be, because we can't say exactly how long this segment is, because we can't count. Okay? So what we're going to do is we're going to use our formula and just plug numbers in a little bit differently. So remember, if we talk about that midpoint, in order to find the midpoint x value, right? So let me label these. That's P, this one's B. If I want to use that midpoint formula, I'm just going to leave a different value not filled in. So if I've got, lost my train of thought here. So if I've got those x's, and it's that x1 plus x2 all over 2 is going to be the x value of my midpoint, in this case the point P, then that's where I'm going to plug things in for. Okay, so I'm going to have my x1 be my 8, doesn't really matter which one. My x value of my y, my x value of my point A is going to be that missing x. So I've got 8 plus some missing x value. Okay, you can call it x sub A, x2, whatever, all divided by 2, and that's going to equal 3, the x value of my midpoint. And now solving an equation, we've done things like this, a two-step equation, where I'm going to multiply both sides by 2 first to get it out of a fraction. That's going to be gone. I'm now going to be looking at 8 plus x of A is going to equal this 3 times 2, whoops, is going to equal the 3 times 2, which is 6. And then all I have left to do is subtract 8 from both sides, and I end up with that x of A equaling -2. So I know somewhere on this -2 is where my ordered pair is going to end up. So then I'm going to erase all this, and I'm going to do the exact same thing, but with my y value. Okay, so now I'm going to be doing this for my y's. So I've got that y of 1/2. I'm going to do the same thing. So the 1/2 and the 3. So 3 plus the y of my A value, all divided by 2, should end up equaling this 1/2. Again, multiply both sides by 2. 3 plus the y of A is going to equal 1/2 times 2 is 1. And then I just go ahead, I subtract 3 from both sides, subtract 3, and I've got that y sub A is going to be 1 minus 3, which is -2. And that's going to go up here, and that is my A value. That's no longer my midpoint. I use the midpoint to find out where A was going to be. And if we make that line, we can see that that P is right in the middle of it. Okay? So I've got one more slide. I'm kind of running out of time here because this puts me on a 15-minute limit. It's a little bit long. I'm still working on getting these videos down. So this video, I'm going to end this thing right here, and then we'll come back for this last slide in a shorter second video so that we make sure that we get all this stuff in.